Welcome to Casense.
Ever been stuck in a meeting where two people are arguing over the best way to improve a project? One person says a new design will bring in more customers. The other insists the current setup is perfectly fine. Without hard facts, how do you know who is right? Often, teams settle these arguments by just picking one option, making the change, and crossing their fingers. If sales go up a month later, they take the credit, but they never really know why it worked or if the change actually caused the boost at all. There is a way to stop guessing and start knowing. It is a process called A/B testing, and it is a method used to figure out exactly how a specific change affects user behavior. Instead of arguing over ideas, you take your audience and randomly divide them into two different groups. The first group sees the website exactly as it is right now. The second group sees the new proposed change. By comparing the precise results of these two groups, you can see how each version performed in the real world. This lets you rely on objective data instead of personal opinions to decide if a change is actually an improvement. Let's look at how this works in practice with a fictional software company named Swift. Swift wants to increase the number of people registering for their service on their website. The team thinks the current sign-up button blends into the background too much. They suggest replacing it with a larger, clearer button to catch the user's eye and drive more clicks. Before making any updates, they start step 1 of the A/B testing framework, forming a strict hypothesis. They state exactly what they are changing and what they expect to happen. In this case, a bigger, clearer button will increase signups. Next, they set up their two distinct testing groups. Group A is the control group. They will see the original plain gray button. Group B is the treatment group, and they will get the bright blue button. Keeping that control group is essential. Without a baseline showing how the original button performs right now, Swift would have nothing to measure the new button against. The control gives you a starting line. Step 2 is splitting the incoming traffic. As visitors arrive, they are randomly routed into bucket A or bucket B. This randomization ensures the two groups stay comparable. By assigning visitors at random, the two groups end up nearly identical. Think about all the invisible differences between your visitors. Some are browsing on their phones, some are on laptops, some are older, some are younger, some are in a great mood, and some are tired. Randomization takes all those different factors and spreads them evenly across both groups. Step 3 is running both versions at the exact same time. Group A and Group B are collecting visitors simultaneously. Testing them together is important. If you tested the old button in November and the new button in December, an increase in signups might just be holiday shopping trends. Running them at the same time helps account for outside factors like seasonality. Because the groups are identical and they are experiencing the website at the same moment, the only real difference is the button. If Group B does better, you can conclude that the button itself caused the change. To keep the results clear, you have to follow the one variable rule. That means the button must be the single, absolute only difference between the two web pages. Imagine if Swift changed the button, but also rewrote the main headline on the page at the same time. If signups went up, they wouldn't know if the new button worked or if people just liked the new headline. Step 4 is measuring results. Group A establishes our baseline, but Group B grows higher, showing a 12% increase. Next, we check for statistical significance. This mathematical verification proves the jump is real and not just random noise. Reaching significance provides the evidence Swift needs to move forward. They can now ship the winning feature to everyone, confident that the improvement was driven by the new design rather than luck. While this process is effective, its integrity relies on following the rules. If those rules are broken, the results can be misleading. A common mistake is impatience. Sometimes a new design looks like a success on the very first day, so teams stop the test early. But without enough time for the data to stabilize, they are often just looking at a temporary fluke. Scale is another factor. If a website only gets a handful of visitors, an A/B test won't work. You need a large enough volume of traffic for the statistical patterns to become clear. And if you skip the randomization process, you lose the ability to compare the groups fairly. Without it, you can't be sure your change was the thing that actually caused the result. When used correctly, this framework is perfect for testing specific changes before rolling them out. It allows companies to settle internal debates with evidence rather than just opinions. A/B testing isn't a magic fix, but a rigorous tool. By respecting its boundaries, you can separate genuine insights from misleading noise. To get those insights, remember the 4 steps. Form a hypothesis, split your audience randomly, run both versions at once, and measure the results for significance. Following this path lets you trade in office guesswork for verified, actionable evidence. So the next time you face a tough choice about a new idea, don't just guess. Build the test and let the data show you the way.